In the interest of keeping this as short as possible, I've done a couple of things to help you with this problem. The example here is interesting. We know that if we don't know the width and the length, we can just label it W and L of this area. We want the area as large as possible. We're given 24 inches of wire. That'd be nice to know. And so we know that when we talk about the distance around the triangle, the perimeter, it's 2W plus 2L, and it's got to equal 24 because that's the most wire that I have. So we're kind of curious about what would make the best choices for L and W. And if we have two variables, L and W, that creates some problems. So we solve this equation for L or W. In this case, we solve it for L. And then we can write this without the L. We can substitute in 12 minus W for L. And then we get it down to one variable, which looks like it's going to be a quadratic. And, quadratics have, they have maximums, right? If they open down, you see that negative W squared. It's going to do this, and that's going to have at the top of the parabola, the vertex, it's going to be a maximum. Okay, so that's what we're thinking about. And also, in the meantime, they have you filling in, for the example here, they have you filling in things that it looks like as W approaches 6, I'm getting to that maximum right there, to the peak. Okay, so in terms of limits, as W approaches 6, then the limit is 36, okay, which is the maximum. Okay, so now we're going to do this problem together. That was kind of the example up there. You create an open box from a square piece of metal, 24 centimeters on a side. You cut equal squares from the corners and turn up the sides. And I drew a diagram already for you, but you might want to think about that a little bit before you look. You have an open box, you have a square piece of, we'll say, metal. You're going to cut corners out, and they're equal. Okay. So here's my drawing. So all these x's everywhere are equal all around. Okay, just so you know. And also the volume of a rectangular cube is length times width. So in this case, this might be the length, and this is the width, and then the height would be how it comes off the page. Comes off the screen to make a three-dimensional product. So anyway, we go on back up here and we see, verify that the volume V of the box is given by V equals 4x times 12 minus x squared. And then they want you to plug in some values for x in there. So do the algebra and show me that this is true based on our setup down here. I got you started here a little bit. But show that that's true. And then plug in values into x and see what you get for v. And then tell me what the limit of v is as x approaches 4. And you can use a graphing utility to graph the volume function up here, this volume function that we found. And it should tell you the maximum. And it'll be verified. You'll see on your graph that that's true. So show me the algebra and give a little sketch of the graph. Thanks.